Imagine looking back in time, 12 billion years into the past. What would you expect to see? Cosmic chaos? The first flickers of infant galaxies? Well, scientists found something that shattered all expectations. A colossal reservoir of water containing 140 trillion times more water than all of Earth's oceans combined. And here's the kicker. We're seeing it as it was when the universe was just a baby, only beginning to take shape. This discovery is like finding a hidden key to the earliest chapter of cosmic history, forcing us to rethink everything we thought we knew about how galaxies, black holes, and even the basic ingredients for life first emerged. So why do some scientists believe this could completely reshape our understanding of the universe? Today, we're diving deep into the secrets of this cosmic-scale ocean. It all started back in 2011, when the Astrophysical Journal published a truly groundbreaking paper. The focus was a quasar, a blindingly bright object known as APM 08279, plus 5,255, located 12 billion light-years away. At its heart sits a supermassive black hole, weighing about 20 billion times the mass of our Sun. This quasar is so intensely luminous that it outshines entire galaxies, acting like a brilliant beacon across the cosmos. The light we see from it today began its journey over 10 billion years ago, long before our own planet even existed. Initially, astronomers were just blown away by its sheer brightness. But then, they pointed their infrared and radio instruments at it and analyzed the signals. That's when they found something completely unexpected: the clear, unmistakable emission lines of water vapor. This was the smoking gun, the direct proof of a gigantic water reservoir. But the real shock wasn't just finding water. It was the mind-boggling scale of it. This reservoir surrounds the quasar's core, stretching across hundreds of light-years. It contains enough water to fill every ocean on Earth 140 trillion times over. Now, to be clear, this isn't liquid water like you'd find in a lake. It's a vast cloud of cold water vapor mixed with dust and gas, with a temperature hovering around -53 degrees Celsius. This single discovery immediately threw a wrench into long-held astronomical theories. It revealed that the early universe was far more chemically mature than anyone had believed possible. We all know that water, H2O, requires oxygen to form, and oxygen is a heavy element, forged only in the fiery hearts of stars and then scattered into space when those stars explode. Finding this much water so early on, when the universe was less than 2 billion years old, means that multiple generations of stars must have already lived and died. It implies that heavy elements accumulated at least 1 billion years earlier than our models had predicted. This naturally leads to a fascinating and profound question. With so much water and so many complex molecules floating around, could life have emerged in the early universe? Well, let's not get ahead of ourselves. The region around a supermassive black hole is one of the most violent and hostile environments imaginable. We're talking extreme temperatures, intense pressures, and a constant blast of fierce radiation. It should be a molecular death zone, a place where complex structures are torn apart. And yet, this enormous reservoir of water somehow managed to survive. That delicate balance between creation and destruction tells us something truly surprising. Complex molecules can, in fact, survive even in the chaotic vicinity of cosmic monsters like supermassive black holes. This opens up an incredibly exciting possibility. It suggests that the basic building blocks of life might be far more widespread and resilient across the universe than we ever dared to assume. The huge supply of gas and water surrounding this quasar also solves another major puzzle. It reveals that the supermassive black hole at its center is still growing. It has a massive buffet of material left to feed on. This could finally help answer one of the biggest mysteries in modern astronomy. How did supermassive black holes in the early universe grow to be so enormous, reaching tens or even hundreds of billions of solar masses in such a cosmically short amount of time? The answer might be hidden in cosmic reservoirs, just like this one, providing an almost unlimited fuel source for their rapid growth. Before this discovery, the prevailing view among astronomers was that the early universe was a simple, chaotic soup of basic elements like hydrogen and helium. Dust, heavy elements, and complex molecules were thought to appear much, much later, only after galaxies had time to mature. But this super reservoir, seen from a time when the universe was less than 2 billion years old, completely flips that script. It proves that young galaxies already possessed all the necessary ingredients for rapid and efficient star formation. Their chemical complexity was far beyond what our theoretical models had ever predicted. Their chemical complexity was far beyond what our theoretical models had ever predicted. The discovery highlights the amazing power of something called gravitational lensing, which is like nature's own cosmic magnifying glass. The light from this distant quasar was bent and amplified by the immense gravity of foreground galaxies lying in its path. Without this natural telescope, the faint signals from the water vapor would have been completely invisible to our instruments. This also implies something tantalizing. There might be many other massive water reservoirs out there, hidden from our view, just waiting for the right cosmic alignment to be discovered. The presence of so much water also forces astronomers to revise their models of galaxy formation. Water is one of the most efficient coolants in the universe. It helps hot gas lose heat quickly, allowing it to condense faster and form stars much more rapidly. This directly contradicts earlier theories, which suggested that early quasars had very limited star-forming potential because they couldn't cool down fast enough. This discovery shows they were actually incredibly fertile nurseries for new stars. To be absolutely sure, scientists recently used even more advanced telescopes to gather more detailed data. They not only confirmed the existence of this super reservoir, but they even began to map how its material is distributed. Now, the research community is racing to answer the next big question. Is this water-rich quasar a rare, one in a trillion oddity? Or is it a common feature of the early universe? If more systems like this exist, it would mean that long before our solar system ever formed, the chemical foundations for life were already widespread across space. The seeds may have been planted at the very dawn of cosmic history. From simple atoms to complex molecules, from the feeding of monstrous black holes to the explosive growth of the first galaxies, this enormous reservoir, 12 billion light-years away, connects so many different pieces of the cosmic puzzle. In the end, it tells us something strangely poetic. From the very moment it was born, the universe carried within it the blueprint for complexity. The water that fills our oceans, the life that walks our planet, all of it might be a gift the universe was preparing long before we ever existed. Thank you so much for joining me on this journey into the early universe. We'll see you in the next video.